Today, we'll complete the chest lid animation and properly adjust the pivot point of the lid's static mesh. Let's get started. In the last episode, we created our BP Storage Master blueprint. Now, right-click this blueprint and select Create Child Blueprint class to create a child blueprint inheriting from the master class. Name this new child blueprint BP_storage_chest, as this will represent our storage chest with a lid. Open the BP Storage Chest blueprint and select the chest component from the Components panel. Assign the chest static mesh to it, and you'll immediately see our storage chest appear. Next, select the chest lid component and set its static mesh to the chest top 1 mesh. Now, our chest includes a proper lid. However, you might notice an issue. When rotating the lid along the x-axis, it doesn't rotate correctly and seems misaligned. This happens because the pivot point of the lid mesh is positioned significantly below the mesh itself, designed initially for easier alignment when assembling the meshes. This scenario gives us an excellent chance to learn how to adjust the pivot point of the static mesh directly inside Unreal Engine, without using external tools. Now, compile and save this blueprint, then return to the map view to proceed. Open the source folder inside the CC0 chest folder. Drag the chest top 1 mesh into the world and position your camera so that you have a clear view of the mesh from an appropriate angle. At the top, click on Selection Mode and switch to the Modeling mode. Modeling mode allows us to modify meshes directly within Unreal Engine without using external tools. On the left panel, click X-Form, which provides transformations such as position, rotation, scale, and pivot adjustments. Then click Edit Pivot, enabling us to reposition the pivot point of our mesh. You can now freely adjust the pivot, for instance, by grabbing the Z-axis handle and dragging it up or down to move the pivot vertically. Additionally, Unreal offers quick pivot positioning through predefined options such as center or left. For our purpose, select left to align the pivot conveniently. Adjust it slightly downward until the pivot fits perfectly for our lid rotation. Some experienced users may achieve this with a single click, but personally, I enjoy fine-tuning the pivot manually for precise control. Now, save your progress and return to the storage chest blueprint. At this point, you might notice the pivot change didn't take effect. The reason is that clicking Save in the map view only saves the map itself, not the pivot adjustments. To confirm pivot changes, you must click Accept at the bottom of the X-Form panel. After accepting the changes, return to the storage chest blueprint, and you'll see the pivot point adjustment has successfully applied. Since we've modified the pivot, the chest lid mesh now needs to be realigned slightly to ensure correct positioning and rotation. If we rotate the lid on the x-axis now, it already looks better, but it still appears slightly off. To further improve this, return to the viewport and click Edit Pivot again. Move the pivot further downward until it aligns exactly with the lower edge of the lid mesh. After adjusting, click Accept to confirm this pivot position, and let's inspect the results. When we rotate the lid again, the motion looks significantly improved. Set the lid's rotation on the x-axis to 10 degrees. This will represent the closed state of our chest. Now, move the lid down slightly along the z-axis until there's no visible gap, achieving a neat and proper fit. The lid now looks correctly aligned. Compile and save the blueprint, then open the event graph to continue. We can delete the 3 default events from the event graph, as they are not required here. Next, we need the 2 interface functions we defined earlier in our BPI storage interface. To add these, double-click Open Storage Lid and Close Storage Lid from the Interfaces section on the left side. Position the Open Storage Lid event above the Close Storage Lid event for better readability. Right-click in the graph area to add a new custom event, naming it Open Storage Lid _multicast. Add another custom event and call it Close Storage Lid _multicast. It's important to set both of these events' replication settings to multicast so that the lid animation synchronizes across all connected clients in our multiplayer environment. Next, right-click again and search for the node Add Timeline, naming it Lid Rotation. A timeline allows us to smoothly animate properties, such as rotation or position, over time. Double-click on the lid rotation node to open its details. Within the timeline, set the total length to 1.00, representing the duration of the animation. Now click on plus track and select Add Float Track, naming this track Rotation X. This float track will allow us to define how the chest lid rotates during the animation. Right-click inside the graph and select Add Key to Curve Float 0 to create our first key point on the timeline. Set the time to 0 and assign a value of 10, as we previously determined that a rotation of 10 degrees represents the closed position of our chest lid. This starting key represents the lid in its fully closed state. Right-click once more inside the graph and again select Add Key to Curve Float 0, adding a second key point to our animation curve. Set the time of this new key to 1, matching the total length of our timeline, and assign it a value of -20, representing the lid's fully open position. We'll verify this open position shortly within the viewport. To clearly visualize our animation curve, click both the Zoom to fit horizontal and Zoom to fit vertical arrow buttons. This will adjust the view to neatly display our complete animation curve. Next, select both key points we created. Right-click one of them and enable the Auto Interpolation option. Auto Interpolation smoothly transitions the animation curve between keys, providing a natural movement for the chest lid. Finally, compile and save the blueprint. Now we're ready to test the lid rotation and confirm the open state at -20 degrees. If we rotate the lid component on the x-axis to -20 degrees, this represents the fully open position we defined previously in the second key of our timeline. For now, let's reset it back to the default value of 10 degrees, the closed position for our lid. Return to the event graph to continue. Next, take the execution pin from the open storage lid _multicast event and connect it to the play pin on the timeline. Similarly, connect the close storage lid _multicast execution pin to the reverse pin on the timeline, ensuring our animation plays forward and backward correctly when triggered. Now, select the chest lid component from the Components panel and drag it into the graph. From its pin, search for the node Set Relative Rotation. Connect the Update Execution pin from the timeline to this node. The timeline provides an output pin labeled Rotation X, which corresponds to the float track we previously created. This track smoothly interpolates the lid's rotation from 10 degrees, closed, to -20 degrees, open, based on the timeline's current position. Since we only want to update the x-axis rotation of the lid, right-click on the new rotation input pin on the node and select Split Struct Pin. Now, connect the Rotation X output from the timeline directly to the new Rotation X input of the rotation node. Highlight the two multicast events and their connected nodes, then add a comment labeled Animate Lid Rotation for clarity. Next, grab the execution pin of the interface event Open Storage Lid and call the Open Storage Lid _multicast event. Do the same for the interface event Close Storage Lid, calling the Close Storage Lid _multicast event. Select both of these interface events and add a comment labeled Trigger Lid Animation to clearly identify their purpose. Compile and save the blueprint. Now return to the map view. You can delete the chest lid top mesh from the world, as we no longer need it. Switch back from modeling mode to selection mode. Adjust your camera to clearly see the area where we'll place our new storage chests. Navigate to the Inventory System folder, where our BP storage chest blueprint is located, and drag this chest into the world. You can place 2 instances of this chest into the scene. To complete our setup, create another child blueprint from the BP_storage_master. Name it BP_storage_box. This new blueprint will represent the box from earlier, which doesn't have a lid. Before we continue editing this new child, let's briefly return to the master blueprint. Select the storage inventory component and change its default slot amount to 1. Compile and save the blueprint. Now, if you open the storage chest blueprint again, you'll notice the slot amount of the storage inventory component has also automatically changed to 1, demonstrating how efficient it is to manage shared functionality through the master blueprint. We now set the slot amount of our chest to 20. Compile and save, then return to the map view. Next, open the storage box blueprint. Here, select the storage inventory component and change the slot amount to 12, as this box will hold fewer items than the chest. Now, select the chest component and set its static mesh to our original wood box mesh. For the chest lid component, leave the mesh empty since this storage type doesn't have a lid. In the event graph, delete the 3 default events. We'll leave this graph empty because our box doesn't require lid animations. Compile and save the blueprint. Whenever the master blueprint tries to trigger the open storage lid or close storage lid interface events, it will recognize that these events aren't implemented in this child blueprint and simply do nothing, exactly as intended. We're now ready to test everything in-game. We set the net mode to play as client and adjust the number of players to 2, so we can test our multiplayer functionality. Now, start play mode. We run to the chest and attempt to open it. But nothing happens, and the lid remains closed. Let's see what's causing this. Exit play mode to investigate, and I noticed 2 things we should address. First, go back to the map view and place our storage box without the lid into the world for testing purposes. Next, open the BP Storage Master Blueprint, click on Class Defaults, and adjust an important setting that I previously missed. We must enable replication for this blueprint. Without replication enabled, events won't synchronize correctly between server and clients. Compile and save these changes. Now, restart play mode to verify our adjustments. Press T to give our players some test items. First, we approach our storage box, without a lid, and place some meat inside to confirm basic storage functionality. Then, we move to the storage chest and open it. On the second client screen, you'll notice the lid now correctly opens. Let's reposition slightly to get a clearer view. Before continuing, we double-check our wood box again and retrieve the meat. Returning to the chest, we open it once more. Even though visibility may be slightly blurred due to multiplayer preview, we can confirm the lid stays open as expected. Switching back to Client 1, when we stop accessing the chest, the lid properly closes, playing the intended animation. Everything now functions correctly, and the lid animation is working smoothly in our multiplayer environment. Should you notice anything unusual, or if you have any suggestions or encounter issues, please let me know in the comments. I will be happy to respond. I would appreciate your like and subscription, as always. Thank you for watching. I'm not exactly sure what the next episode will cover, so feel free to be surprised or share your ideas either in the comments or directly on Discord. See you next time.